Hello everyone, welcome to the channel. In this video, we will see a problem on Newton's second law or else D'Alembert's principle. The problem states that a 50 kg block kept on the top of a 15-degree sloping surface is pushed down the plane with an initial velocity of 20 meter per second. If the coefficient of friction between the block and the surface is 0.4, determine the distance traveled by the block and the time it will take as it comes to rest. Okay, so in this problem they are not given as a diagram. First of all, we will try to draw the diagram based upon the given data. So they have given the slope of the sloping surface 15 degree. So first of all, I'll draw the 15 degree sloping surface, and we have a block of 50 kg. We have a block of 50 kg. Okay, so this is a 50 kg block and it's pushed down the plane. That means the acceleration of the block is downward. Acceleration is downward, so as its direction also. So direction of the block or its acceleration is downward. Okay, now what all forces will be acting on the body? So first of all, the normal force will be perpendicular to the body. This is the normal reaction force. Then since the direction is towards downward, on the opposite sides we'll have a frictional force, that is mu dot n. Okay, and after that we'll have a weight of the body will be acting downward. So weight of the body will be acting downward. So it will be acting downward. So from the center, the weight of the body will acting downward. So I'll draw the weight in this direction. So this is your W. Okay, so these are the forces will be acting on the body. Okay, so if you see all the forces, we have one force, that is a weight which is inclined with the axis of the block. Okay, so we have to find that what is the inclination. Okay, so like this problem, that's a simple method to find the angle. So I'll just give you a hint, small one. So first of all, you can consider the big triangle. If you see this triangle, if you extend this, even this is a triangle, right? So I'll just make it a shade. So this is a triangle. I'm going to redraw this triangle over here, right? So we know this is 15 degree. Okay, so this is 90 degree because it is perpendicular acting to the body. This will be 90 degree, and we know that the sum of the triangle should be equal to 180 degree, right? So if you add 90 plus 15 and minus of 180, or else 180 minus of 90 plus 50 will get us 75 degree. Okay, so this is 75 degree. Okay, so we found out that this angle is 75 degree. So now what I'm going to do is I'm just extending this. I'm going to extending this triangle as well. So I can draw this as one triangle, small triangle. So over here, okay, so we know that this is a weight acting downward, this is a weight acting downward, so this will be 90 degree, this is 90 degree, and this is 75 degree. So again we know that sum of all the triangles should be equal to 180. So 180 minus 90 plus 75 will get us 15 degree. Okay, so if this is 15 degree, this is exactly opposite, congruent opposite triangle, this will be 15 degree. So in general, we can take the angle of the weight similar to the sloping angle. Okay, this is the explanation you can take. Now we have an inclined force, we can resolve into two component, x and y component. Since the direction of the weight is coming downward, so this will be the component will also be inward. This will be weight of okay, here you will have a sine 15 degree because we have a angle with respect to y-axis. So this will be your cos theta. This will be cos 15 degree. Okay, I hope you understood this diagram. Now we are supposed to find the now what we can do is we can write down the given data. So given data, so first of all they have given the mass of the block, mass, this is equal to 50 kg, and they have given the mu as well, mu equal to 0.4. then they have given the initial velocity, initial velocity is u equal to 20 meter per second, sorry. And okay, so these are the given data, and what are the parameters we have to find? The first one is we have to find the determine the distance traveled. So determine the distance traveled, that is, I can write it as s. And the second one is time take to comes to rest time taken, right? So time is t. Okay, so these are the parameters you have to find. So how can we solve is that? So we can use the Newton's second law formula. Solution. So by Newton's second law of motion, we know that f of x equal to m into ax. So here we have to frame all the x direction force. So if you see, we have in x direction we have this direction w sine 15, and the direction of this is similar to the direction of the acceleration, so it will be positive. First I'll write down that. So positive weight sine 15 degree. Then after that we have one more horizontal force, that is a mu dot n. Okay, so here this is a frictional force opposite towards the direction, that it will become minus. So minus mu is 0.4, so we don't know n. So n, this will be equal to mass of the block is 50 kg, and we don't know the acceleration as well, this will be ax. Okay, so we know that w is 50 kg, so we need in the Newton, so 50 into 9.81 into sine 15 minus 0.4 n equal to 50 ax. So if you can use f of y equal to m into ay, here in y direction the box is not moving, so ay will become 0. So in y we'll have two forces, that is n. In y direction we have two forces, vertical forces. We have n positive, and we have weight into cos 15. So positive n equal to positive n minus downward is acting downward, so weight is 50 into 9.81 cos 15. So this will be equal to 0 because ay is equal to 0, box is not moving in vertical direction. So n will be equal to, we have to use the calculator. So 50 into 9.81 into cos 15. So I got the value as 473.786 Newton. So this is the value for normal. Now what we can do is we can put it in the equation of fx to get the value. We can frame an equation over here now. So this is will be 50 into 9.81 into sine 15 minus 0.4 into 473.786. This will be equal to 50 into a. Okay, so we can find out the acceleration from here. This is 50 into 9.81 into sine 15 minus 0.4 into 473.786 and divided by 50. So I got the value as a equal to minus 1.25 meter per second square. So here in this problem we got the a as in minus. Okay, now we found out the acceleration of the block. Now the first step to find the time, time and distance. So this can be found by using equation of motion. So we know that we have three formulas in equation of motion. Okay, so if you know this formulas, we have the relation between v equal to u plus at. Here we know that u equal to 20 meter per second. Okay, and here the velocity, the final velocity will become 0, because we need to find the time when the final velocity is equal to 0. That means when the body comes to rest. So final velocity is 0 over here. So we can put all this equation data in the equation, that is 0 will be equal to 20 plus, we know the acceleration, that is minus 1.25 into t. So if you do the calculation, we'll get t equal to 16 seconds. Okay, so we found out one sub question, that is time, and again by using this same equation of motion we can find out the distance. So we have a equation s equal to ut plus half at square. So here in this equation we know u, that is the initial velocity, is 20, we know time, that is 16 seconds, plus a half into minus 1.25 into 16 square across time square. So if you do the calculation, we'll get s equal to, the distance is equal to 160 meter. Okay, so here in this problem we started with the D'Alembert's principle or Newton's second law. We found out the acceleration. From the acceleration we found out the velocity, or else we found out the time and the distance by using equation of motion. Okay, so I hope you understood this problem clearly. If you have any doubt, you can put it in the comment section. Thank you guys.